Alrighty then. I love the rock and roll there. So my name is Sean Hackett. I'm Managing Director at 451 Research. We're a research firm similar to Gartner and Forrester and others in that we have a syndicated business. We also do a number of other things. My specialty tends to center around data center, cloud computing. So I have this session here about rock solid data center solutions. I have three great panelists here. I'll have them introduce themselves quickly because I know I'll struggle with the names. So I'll have you guys do that. Why don't you start?
Long and complicated name, just go by DD, first letter of my first name, first letter of my last name. My name is pronounced as Dhritiman, not to be mistaken with Dirty Man, which I've got a few times.
I'm Dominic Wilde, so I run product management for HP Networking.
I was here, so I'll give you back 30 seconds.
Perfect. Okay. So, I love starting out with this. The cloud changes everything, right? And I usually have a question mark on it because I'm not so sure that I agree with this, right? So I usually have people that give me the roll of the eyes, and and I think really what's important here is how we define cloud, right? So I've heard integration as a service. Bare metal as a service is a new one from SoftLayer, I think is interesting. And what we've really done is we have taken the definition and the IT industry has sort of wrapped it around the boundaries of technology, and that's not what it is at all, right? If you tell me that cloud computing is a new way to consume and deliver resources, then it is going to change everything. I mean, the fact of the matter is cloud is changing everything because end users are ticked off, right? I mean, IT's become the organization of no, and they just speed, and they don't have the speed, they don't have agility, they're soaked by software providers who milk them for maintenance costs for years, and so it just got to a point where that is really what's driven the market forward. IT CIOs could care less about how we define cloud. What they want to do is they want to take workloads and applications, map policy against them, and find the best execution venue for them. It can be internal, it can be external, it can be cloud shared, it can be cloud dedicated, it's all about choice, and it's all about optimization, right? So with that intro, one thing I'm not doing here is saying that there is going to be 4 massive data center providers that rule the world. That's not what I'm saying, right? Keep in mind that I said it's all about choice, right? There can be micro data centers, latency sensitive applications where, latency and proximity is an issue. And there's also going to be a number of, we talk about the Internet of Things, we talk about batch processing, massive amounts of processing that have to happen. And that's going to happen in some fairly big data centers. And there's some disruption, and this is what I want to focus the panel on is disruption. So how this ticked off user base and how cloud has really disrupted the whole value chain, right down through the facility to the network, et cetera. So these are these big billion-dollar data centers, right? The one up here on the left is Apple's. The one over here is for the NSA. Big, massive data centers, 15, 20 times the size of a soccer field. Google's, I think that's in Great Plains. I've been there at that one. But the one that's really interesting that made me create this slide was I had a discussion, tell you a little story, I had a discussion with Christian Blady at Microsoft. And this is Microsoft's new Boyden, Virginia data center. And it's really interesting on a number of, for a number of reasons. One is it looks different than the others, right? I mean, it's outside, it's open air cooling, it's modular. I mean, they drop those big, they look like big transportation rigs onto slabs, and That's how they expand. So it's a modular build. The really interesting thing for me, though, is there's no generators, right? So what's happening, the more I talk to Christian, what's happening is we're moving to a world where they have this software resilient data center. He said to me, if stuff goes down, I don't get called anymore, right? And that's a paradigm shift. So it's this disruption down into the facility that will drive change into the network, which is where I'm trying to go with this. And it's going to be, what's going to be really important is how do you build an ecosystem, right, where you can ensure this resiliency. And it's not the resiliency of the facility, it's the resiliency of the service. I mean, for data center folks and facilities folks, I mean, we own Uptime Institute. It's a bunch of facilities guys. When we talk about this, their hair stands up, right? This is a real radical shift. And the implications on the network are pretty big, right? So we have, I mean, the way that networks have to be architected if this is going to happen is you're going to have workloads and mobility, VM mobility happen where workloads are spread out, the real essence of distributed computing. And the architecture of the network is going to change. You can't have a tiered architecture anymore. So what happens with protocols like spanning tree as we move to flatter networks, we move to Trill, there's lots of discussion here about software-defined networks. There's implications on security and server bandwidth. I mean, we talked a lot about bandwidth and Ethernet, and really data centers will need to be more scalable and more application fluent if they're gonna sort of make it in terms of how we move to the next generation. And just keeping in line with Ethernet and the discussions here about Ethernet, we are seeing, this shows results of interviews with end users, gigabit Ethernet to the desktop, 10 gig Ethernet to the backbone. We're seeing accelerations in all these services as demand rises and we see more of that sort of east-west server-to-server traffic and bandwidth is expanding, et cetera. So without further ado, I'm going to now turn it over to each one of the panelists and they'll go through a 4 or 5 minute presentation.
Okay. All right, so this is... Hello? Yeah, so this is a different part of the panel, right, where we actually get to use slides, just changing it a little bit, right? So the problem is, what is our data center strategy and how do we use networking to enable what's going on? So it's kind of a four or five slides to just, talk about the networking and the data center of the future, okay? Dell strategy, everybody knows we have transformed from a PC company to a full end-to-end IT service provider company, gaining market share on servers, networking, storage, software services, and providing the whole end-to-end IT stack, right? So no introduction needed, but that's the value proposition of the new Dell, right? Now, having said that, we mentioned and talked about, the traffic pattern change. This is fundamentally the disruption that our legacy infrastructure cannot cope up with, which is the traffic is going east to west, meaning server to server, VM to VM, as opposed to user and internet or user to the data center, right? And that's what east-west is. For those of you who have heard the term but do not know where it's going, you got campus on the left, coming into a data center, whether it's a rack or a server or a blade infrastructure, right? And these are the workloads that allow these kind of traffic patterns to change, right? Whether it's a VM migration or virtual desktop or any of the Hadoop implementation, right? So just keep in mind, new workloads require new architectures. Legacy architectures won't scale in the data centers. Then we get to the logical aspects, and we have talked about SDN, so I won't spend too much time on it. But as I said, there are 3 camps on how to solve the problem. There's a camp that says, I'll take my legacy environment and allow it to be, programmable. It's still legacy, and we got you by the margins, but you're there. There's a camp on hypervisor on the top that says, don't touch the physical network. Okay, we will allow everything in the virtual world. Well, they expect the network to be there. there is a problem there. You need more connectivity. And then there's the purist, as I said, open flow, based, and the challenges there is what do we do with the investment. So our strategy from a networking perspective and Dell is allow for the transition, allow for the hybrid approach, but focus on the purest next generation deployments based on the use case. Okay, and I think let's see. With that, I think what I would say is where are we heading? Where are we heading is you have very discrete server, storage, network, compute, software elements that are being discussed in the industry today. And we all have a different point of view on that. But my point of view and how Dell sees the things is this is all going to come together and look like this, which is a system of unified management where the boundaries of server, storage, and network are completely redrawn and invisible to an end user, because all they want is, as Dan said it very well, what's my business application? How do you link it to the infrastructure below? And not just network, but the infrastructure below. Okay? So that's my 2-minute kind of overview. And I'll hand back to whoever's next.
Perfect. Next is HP.
Okay, so I'll keep this short and sweet as well. So at HP, we believe in simplification. At the end of the day, that's what is needed in the data center of the future. That's what's needed in the data center today. So what we believe is that in a virtualized world and a world where we have to service applications, we believe the customer needs to spend less time on managing the infrastructure and keeping the network alive, and spend much more time on focus on the quality of the business experience. In other words, making sure that they are delivering the services that they need to deliver in the way that they want to do it. Now, today, the problem we have is that most of the time that's not possible because traditional networks have been configured by trying to guess some future state of the network, some future state of an application or some future need of an application, and statically configure a network. And that just isn't going to work anymore. So what we need is the ability to dynamically enable the network to service applications and indeed allow the application to program the network. So the SDN panel that preceded this talked about many of those points. In our world, we've developed an architecture based around a simple premise. One size does not fit all. The data center has segmented. You can't build one architectural design that satisfies everybody's needs. You have enterprises of various sizes. You have hyperscale customers who are building out thousands and thousands, if not hundreds of thousands of servers. You have service providers who wish to deliver new and innovative services to a broad, globally distributed customer base. So one size is not going to fit all, and the important thing is that the form factor in which we deliver the network has to fundamentally change. And we've already started doing that with developments like our Moonshot server enclosures, which deliver ARM-based processors, thousands of servers in a single enclosure with the network fabric integrated already in there, and the ability to have that fabric act in unison with the rest of the fabric. Those are the kinds of innovations that are going to be needed going forward. And it's not just about simplifying the fabric, it's also about enabling that fabric to be policy-driven. And as Sean mentioned, as you move forward, the policy, the business policy is what you want to focus on, and the network needs to be responsive and reactive in being provisioned. And then finally, it's not just about the fabric. The delivery mechanism, how we actually physically deliver our data centers, how we enable them to be stood up, is incredibly important as well. And so power-optimized data centers, or pods, and the EcoPod, which HP invented, enables you to deliver thousands of servers, whether they're physical or virtualized, optimized and already configured with the network fabric ready to go, drop-in style alongside an existing data center, or to build out and scale out new data centers as well. So there's a lot of innovation in these areas that we're going to see coming.
And next up, and I don't believe you have a presentation, but is Juniper.
Thank you. So I decided not to use slides, instead tell you a story. About 5 years ago, I joined Juniper, and it was about the time where the founder of the company and CTO, Pradeep, and a bunch of architects basically tried to solve a really tough problem. And the problem was as follows. If time, money, resource, and revenue were not an issue, if we could build the entire data center network all over again, what would it look like? We actually didn't have a nice problem of about $12 billion of business that we were doing in data centers, so we could come out and say what we wanted to. So we started looking at and started asking ourselves, who taught us how to build data center networks? A lot of times I get the answer Cisco, but that's okay. The answer actually lies in history. It's the same folks who built campus networks, and as Arpit was pointing out, there's a fundamental difference between the traffic flow pattern in campus networks, predominantly north-south, and in the data center, it was predominantly east-west. So we said, why do I have a north-south network, this tree-shaped network that we see in the data centers? So we decided to go absolutely clean slate. We said, okay, what are the fundamental problems with that architecture? It boiled down to three. First, that network is slow. I started my career as a chip designer. I used to build networking chips. Now I wear fancy clothes and present at events like this, but still remember a few things from my chip making days, which is every chip, every switch, every router, anybody who's ever built it, there's a huge amount of time spent in doing just one operation. And that operation is opening up a packet, seeing what's inside, closing the packet, and sending it to the next guy. So essentially, that tells you the number of switches you're going to traverse. You're going to repeat that same redundant packet processing operation. In a data center, if server A wants to talk to server B, ask yourself, does the first packet, when it hits the first switch, does it know where it wants to go? Absolutely, absolutely. But it's that ridiculous architecture that makes that same operation repeated over and over and over again. Complete waste of time. That's what we thought. The next big problem we saw was with the management of the network. Yes, as an industry, we keep building bigger and faster boxes, but there has been no innovation until, I think SDN has the promise of fundamentally simplifying how we manage networks. So we said in a data center, which is 30, 40, 100 switches, think about the pain the network administrator goes through to manage, configure, tweak, not only the individual devices, but the interactions between the devices. We call these protocols, 3, 4, 5-letter fancy acronyms. Right? But do you think network operators love it? Absolutely not. It's a big pain. And that's what gets in the way of delivering the agility. So those were some of the problems we found, that networks were inherently slow, repeated packet processing operations, management of the network was an absolute pain. So we said, okay, in the past we took inspiration from the campus network and replicated in the data center. Is there any other network we can take inspiration from to build the perfect data center architecture? Actually, there is a network which has been sitting in front of all of us for the last 25 years. It's a network inside a switch. If you think about it, every switch has a network inside. It's the network that connects all the ports together. Instead of the ports, think servers. Think about that network for a second. Are there any protocols inside a switch? Is it 2-tier, 3-tier, 5-tier? No. Every port is directly connected to every other port. The performance is predictable. A switch does not have biases between the kinds of traffic. And what's most important, you do not manage each of the ports individually. You manage the whole switch as a single entity with a single IP address. Instead of protocols, we've got this notion of shared state in tables. And we've given these names over time: MAC address table, routing table, security table. But the idea is very simple. All the ports don't start exchanging information with each other. Instead, they look at these global tables, treat them as the Bible, and say, I know what I need to do. So we thought about that network. Said, is it possible to take that network, which has been trapped inside the physical confines of a single switch for the last 25 years, can we take that network and bring it out to the data center? And that's exactly what we did. I won't get into the details of QFabric. That's the product where all of this got instantiated. But think about it this way. Data centers have had to make a compromise between speed, reliability, and scalability. You can have a really big network, but it's going to be very difficult to manage. you can have a really big, you can have a very big network, but it's going to be very slow. Until QFabric, there was no solution that does all three at the same time. And my friend Dom mentioned that one size does not fit all. I absolutely agree with it, but one architecture can fit all. If you can get the benefits of speed, if you can get the benefits of reliability, and have the entire data center managed as if it were one single switch with one IP address and one configuration file, that in my mind is the perfect data center network. In 10 years, every data center needs to be built this way. So with that, I'll end my discussion.
Great, thank you. So we had the rock and roll and the head-to-head, and so usually I save this question for the end, but I'm going to throw a little curveball and ask it now. Each of the vendors come up and we sort of hear the elevator pitch, and I don't know, at least for me, things kind of sound the same. And what I'd like them to do, and I'll start with Dell, is to tell me why your approach is different than the others.
Yeah, so I think, once you get to the basic trends, check, everybody, is going to say the same thing. When you get to basic problems that we have all solved, everybody's going to say the same thing, right? The approach to get to a solution is different for different. So for us, our focus is different in terms of we design for a scalable design point. What that means is our solutions are architected for the largest section of the market, which is really what we call the mid-market, and then when scale it up and scale it down, right? Versus starting very high end and then dragging it down, right? So the design philosophy of that is different. And the second thing that is different from the specialist vendors is that we solve the problem in a holistic manner. Software, clients, devices, all the way from thin to thick clients, all the way into the data center and campus, end to end, and break the boundaries of conventional thinking, whether it's server storage, computer, networking, software, et cetera, right? So I think from a single vendor traditional approach, specialist companies, we differentiate from that perspective, and from the other larger players, we are focused on a section of the market that requires a scalable design point up and down, right?
Okay, so it was design philosophy, holistic approach, end-to-end. I mean, it sounds a lot like what HP would say. I mean, how is...
Yeah. So yes and no. I think, as the largest IT provider in the world, we have some unique capabilities. It's not always just about the technology. The technology is obviously very, very important. We all have our different approaches to that. But it's everything that you can wrap around that as well. It's a level of trust with customers. It's a level of access with customers. It's the fact that we have the breadth of offering and technology across our entire business, everything from the desktop all the way up through the data center and beyond. But I think the other important element is the services element as well, is being able to actually consult on this. But I would say one other thing, that from a networking point of view, but this is true across the whole of HP as well, we take a very transformational approach. You hear a lot of vendors talking about, hey, look at my nice shiny bright object, and it's a better architecture than that guy's. At the end of the day, what the customer is interested in is, I've already made an investment, I already have some sunk cost. How do I get from here to there? That is what we find that people are struggling with. And HP is in a unique position to help them to solve that problem and understand the transformation journey and to actually execute on that.
Good, and...
Let me spell out what transformational means. QFabric delivers end-to-end, server-to-server latency of 5 microseconds or less. Let me put that in perspective. Any switch out there, the time it takes for a packet to travel a single card on a single switch is in the order of 15 to 20 microseconds. That's one switch. I'm talking about end-to-end in 5 microseconds or less. Let me give another example.
Legacy switches.
Yeah, that's fine. Let me give you another example of transformational. Think your data center has 6,000, physical servers. you would need at least 125 switches to connect all of these, 6,000 physical servers, right? Which means at least 125 configuration files, licenses, an admin staff of at least 20 people to manage that infrastructure. Transformational would be one admin, one configuration file, all 125 switches looking like one switch with 6,000 ports.
Good. So just another few questions. I guess the next question for me would be pick the most disruptive event that you think is going to happen over the next couple of years in the data center, and then help us understand how you would address that disruption. And I'll start with you.
I think it's the sheer growth of data, and we're all in the business of data transfer. Data transfer is typically 10x higher than the rate at which data is getting created. So just going to keep, data is going to dominate. I mean, it's by far the biggest trend.
So it's data. So how
the ability to handle, the sheer amount of data that's hitting the data centers today.
And what makes Juniper unique to solve that?
Well, it's the scale of the solutions, it's the elegance. So think about it this way. The reason why I think a lot of customers are scared or shy of taking their entire data center, converting into a whole private cloud infrastructure, is the complexity, right? You can scale up to a certain point, but at a certain point, it becomes so complex to manage that infrastructure that customers actually scale back, and what you get instead of a big cloud is cloudlets, okay? And so what I'm talking about, with the explosion of data, you need these large resource pools so that you can effectively share the load of switching, routing, processing applications, what have you, but being able to do it without adding the complexity. And that's where I think Juniper has a unique advantage.
Okay, couple minutes apiece, HP and then Dell.
I actually think the ability to address the data explosion is just table stakes. I think a couple of the bigger transformations that are going to occur is really one around the transformation in the organizational structures themselves, in terms of breaking down of silos and things. I think that's a fairly large sea change. But I think the bigger transformation is actually going to be around the focus on the application and the move to, the real move to the as a service and cloud. And today, HP is perfectly positioned for this. We invented converged infrastructure, so you converge the infrastructure, so you can't just come with a network story. You have to come with a converged story that talks about how the network is deeply integrated with storage and with the server edge as well. You can't have standalone network story anymore. And then that transforms into a software-defined data center, as we talked about, software-defined networking this morning. A software-defined layer which defines a business policy that drives that infrastructure, and then about the application delivery of services, which is the sort of convergence of cloud. So how do you move from the public cloud to the private cloud, back and forth, through the hybrid cloud, and how do you get these different cloud models to transform and interact with each other? Those are the big, the three big major trends. It's converged infrastructure, it's software-defined data center, and it's convergence of cloud.
Yeah, so we all know and have heard enough trends, so I'm not going to talk about that. I think in my mind, the things that are happening that are really, really disruptive is, what I call software-defined, enterprise or everything, right? You start off with, what's a software-defined PC or a laptop? Well, it's a thin client, VDI, right? You go from there to software-defined storage, software-defined network, right? Software-defined servers are already here. It's called VMs, right? So point is, as these elements of traditional hardcore physical separation of boxes and infrastructure, break these boundaries and cease to exist as we know them, the power of how to solve the problem shifts. And that's where I agree with the organizational challenge, because let's face it, if you have $100 to spend in IT, in a data center, 70 of those go to the server guys, 20 to the storage guy, 10 to the network guy, typically, if you look at the market sizing also, right? The guy who has the most money is going to dictate how it looks like. And so server admins are becoming converged admins, and they need to look at network very simplistically, point and click, no CLIs, right? So that trend, and we've talked enough about SDN, is what's going to change the way data centers are built in the next 2 to 3 years. And technologies from us are there today, right? Breaking the boundaries.
Okay, great. So just to wrap up, we have another couple of minutes for questions. Any questions in the audience? Come on, I know you're all hungry, but there's got to be.
I think we're competing with a break.
Yeah, I know.
Pre-lunch malaise.
Going once, going twice. Okay. Well, thank you, everyone, and thank you. That was a great panel, and thank you all for your attendance.
Thanks.
Yep, thanks.